The monetary valuation of environmental goods and services that are not traded on the market is difficult, and therefore it is expensive. If you do a kind of pricing study and you have all the data already at your disposal, then it will take you 6 to 12 months. But if you do a travel cost study and you need to collect the primary data first, then you're talking about 12 to 18 months. Contingent valuation or contingent choice, because of all the pre-tests that you need to do and all the validity checks that you need to do, you're easily talking about a 24-month study. So it is expensive. And even though there are many valuation studies that have been published, they are nowhere near covering everything we want to know. So if you want to know the value of paddleboarding in a particular lake, if you don't have a primary study for that lake, then maybe a study for a lake that is nearby. And then you can simply extrapolate from the nearby lake to the lake that is of your interest. It may be that that study was done in 2005, and you're going to assume that the same value holds in 2020. Or you may have a study of the value that people attach to the damage done to forest by acid rain, and you're going to use that study to estimate the value of damage done to forest by climate change. So there's all sorts of extrapolation going on in the if you want to advise a court or if you want to advise policy or something like that. This extrapolation is known as benefit transfer. It's particularly important for climate change because climate change affects basically all ecosystems and has widespread effects on the environment. And we simply do not have studies, primary studies for each of them. So we need to extrapolate from the case studies that we have to essentially everything that is affected by climate change. And furthermore, we need to extrapolate to the future, because we definitely do not have any study of how people value biodiversity in the year 2060. We have how people valued biodiversity in 2018 and in 2005 and in 1971, but not obviously in the future. So we need to extrapolate. There is no escape there. Now there's two approaches to benefit transfer. One is the value transfer, that you simply take the value of this lake and impose it on a different lake. We don't do that anymore because that turns out to be simply wrong. What people nowadays do is so-called function transfer. Still a benefit transfer, but essentially you write the value of the thing that you're interested in as a function of the characteristics, say, of the lake, but also the characteristics of the people who responded to your particular survey. It turns out that benefit transfer is difficult, and the reason for that is that values that people give, the answers that people give to a contingent valuation survey, or the values that people express through their recreational choices or their behavior on the housing market, those values are context specific in ways that we do not fully understand. There's all sorts of issues going on there, and we simply haven't got a good grasp on this. There have been many tests of benefit transfer. This is the first third or so of a relatively recent review of benefit transfers that was published. There's a whole bunch of different authors, so this is not limited to a small group of people, but there's a whole bunch of them. All sorts of different methods were tried, all sorts of environmental issues were tried. And then what you see is that sometimes they get it wrong by 20%, sometimes they get it almost right by 3%, and sometimes it goes dramatically wrong by 680%. Now this table goes on and on and on. Here we're looking at the histogram of the transfer errors. So estimated the value of a particular site for a particular issue with a particular time, and then from that you predicted the value of a different site, or the same site for a different issue, or the same issue in the same site for a different time. And this is the full histogram. Then they removed outliers, removed quite a few. And even if you're optimistic and say, well, let's just focus on the quality studies, then you see that it goes in a fairly large fraction of studies. It just goes wrong in the sense that they're 100% off. But even if you say, well, let's focus on the first 40% or so, then you see that there's still a large amount of error. So this is around, this is 20% wrong, or 20% or less wrong, 20% to 40% wrong, and that is actually quite a margin of error. So this is simply difficult. This is another study that did something similar. It is actually down in this table. Marianne Sanderson is mentioned, and here you see her face. She got her hands on two data sets. The situation here is Denmark, and every 20 years or so there is this major study of people recreating in the forests of Denmark. There's, I believe, 59 forests in Denmark, and it's a major survey. Every forest is visited, and lots of visitors to that forest are interviewed, and all sorts of questions are asked. How did you get here? How much time did it take you? How much money did you spend on getting here? Why are you here? Are you walking your dog, or going for a wander in the forest, or are you building a tree hut or something? With whom are you here? Friends, families, on your own, and so on and so forth. They ask all these questions. And Marianne got her hands on this data for 1977 and for 1997, and she estimated the state-of-the-art travel cost model for this, and then predicted the value of these forests per square meter. So she first did that for 1977, and then she did that for 1997, and then based on the 1977 data and results, she predicted the value for 1997, and then compared it to the estimated value for 1997. And here are the results. And for some forests, she got it right. So there's forests on the horizontal axis, and how wrong she got it, or how right she got it on the horizontal axis. For some forests, she got it right. Transfer errors that are basically zero. For some forests, she got it spectacularly wrong. That is 750% off, and that's quite a bit. And then she cheated. So what is going on here is the forecast from 1977 for 1997. Here she did the same forecast, but now she knew how family composition was changing, had changed in that 20-year period, how car ownership had changed in that 20-year period, and so on and so forth. So here in this particular forecast, this particular benefit transfer, she did not forecast what 1997 would be like from a 1997 would be like from a 1977 perspective, but she knew what 1997 would be like. And even if you feed in this information, which you typically do not have, the transfer errors are enormous, up to 400%. Now, this is an easy problem. So it's a travel cost method. So this is revealed preference. So we don't have all to account for all the biases that come with state preferences. That's one advantage. And second, This is a 20-year period in a country that is fairly stable. Denmark changes but doesn't change that fast. And even for this relatively simple problem, she was not able to accurately forecast how values change. If we're talking about a problem like climatic change, we're not talking about predicting the values of Denmark in 20 years' time. No, we're talking about predicting the values in Denmark in 80 years' time or in 200 years' time. Those things still matter, which is a much more difficult problem. And we're not talking about value change in a stable society like Denmark, but we also need to do this for rapidly changing countries like Burma or Bangladesh or Colombia and all those places, which makes the problem much more difficult. And it's not just that. We can do this for Denmark. Can't really do this for the Central African Republic because people might shoot at you or do other nasty things to you. So we also not only need to extrapolate from Denmark in 1977 to Denmark in 1997. No, we also need to extrapolate from Denmark in 1977 to the Central African Republic in the year 2100. So you can imagine the amount of error that is introduced in this way. Unfortunately, there is no alternative. So we have to live with this kind of uncertainty.